So our next topic is how we keep track of movement in physics. And this is just as important as how we keep track of position. So there are really two common ways to define movement: velocity and speed. Okay? And I'm just going to say velocity is based on displacement, speed is based on distance covered. And I'm going to illustrate the difference between the two. So if you remember, we denoted displacement with the variable x, okay? And we denoted distance with the variable d, okay? So when you keep track of movement, you're keeping track of changes in these quantities. So I'm going to put a delta in front of them, okay? And this upside down triangle is just telling me a change in the variable is what I'm measuring here, okay? So delta x is a change in displacement. Let me illustrate this concept with the track example again, okay? So we have our 100-meter track. We have our runner at the starting line, okay? And now he runs around the track, except now we need a time. And he runs around it in, say, 10 seconds, okay? So now, first off, let's think about what is his distance, okay? So his distance equals 100, as we determined in the last video, because 100 meters, because he went around the track. And his displacement, we said, was 0, right? But what we were actually talking about here is what his final displacement was and his final distance, right? But to measure a change, you need two things to compare. So what you actually compare is his starting displacement versus his final displacement, okay? And he also started at x equals 0, right? So to compute delta x, we would take his his final displacement, which is 0, minus his initial displacement, which is 0, okay? So that just equals 0, okay? So his change in displacement is 0. Now let's compare this to the change in speed. Okay, so his change in distance, well, he started at d equals 0, right? So at time equals 0, he's just standing at the starting line. He hasn't gone any distance yet. When we finish, he's at d equals 100. So actually, I'm going to go to a new page now. Delta d for this guy was 100, okay? Which is different than delta x is 0, okay? So to actually talk about what velocity and speed means, we have to talk about how these change in time, okay? So velocity is actually defined as v equals delta x over delta t, okay? Where delta t is change in time. We already determined that it took the runner, we're going to draw the track again, the 100-meter track. We said he ran around it in 10 seconds, okay? So delta t is actually 10. I'm going to write this. This is important because it's used in both the computation of velocity and the computation of speed, okay? So delta t is 10 seconds. So now velocity is delta x over delta t, which equals, well, we take this 0 down, which is our delta x, over our delta t, which is 10, and that's just 0, okay? So his velocity is 0, and this is an important result. Now let's compare it to his speed. So his delta d is 100, and speed, which I'm going to call s, is defined as delta d over delta t. So you can see if you plug these in, you're actually going to get, well, delta d is 100, so 100 meters, divided by, we said delta t was 10 seconds, right? So that equals 10 meters per second, okay? So that's his speed. And from the previous page, we have that his velocity is 0 meters per second. So let's think about these quantities, and I hope you can see it has a lot to do with how we measured position. Okay, so we can say his velocity is 0 because in the end, he just went in a circle, right? He started here, he went around, he ended here. He's not getting anywhere. So velocity is a measure of how you're changing your displacement in time. And effectively, when you're going in a circle, you're not really changing your displacement in time. Whereas his speed is telling us on average how quickly is he going around the track. And I hope you can see that's actually a more meaningful quantity when you're talking about someone running around a track, because when you tell someone I went to run a mile, your final velocity may have been zero because you start at the same place you began, and that forces your velocity to zero because delta x is zero. But the more relevant thing is your speed was 10 meters per second. You were moving. So I hope you can see that the two, like the measures of position, measure different ways of moving.